So, hi everybody. My name is Don Vosburg. I'm on weekends. I'm down at vosburgs.org, an update enthusiast. I was just reminded by a longtime friend of mine today that I am in fact addicted to updating. So that is a good reason to be a systems management product manager, which is what I do during the day for SUSE. I've been at SUSE since 2003. And now I'm, as of September, product manager for our systems management portfolio. And behind it is Uyuni, and that's what we're going to be talking about today. So what is Uyuni? Uyuni is a scalable systems management solution focused on Linux systems. We don't really care where they are. And in fact, we have more than 16 Linux distributions that are a part of what we support. And it's most of what large organizations are running. You'll see some of the lists of those later on. But you can deploy them with tools like Kickstart and AutoYast, or with operating system image building like with Kiwi. And you can put them wherever they are, and you can manage them from wherever your Uyuni server happens to be. You can do both hardware and software inventories of the client systems. You get configuration management built into the system, so if you don't already have Ansible or Salt or Chef, Puppet, those kinds of things, SUSE Manager and Uyuni are Salt masters. So it already comes with the infrastructure for you to run advanced configuration management, declarative Salt states built into the box, and very granular control over content delivery. So for example, if you have test, dev, production systems, you can align RPM content or binary package content. If you're on the Debian side, it's Debs, and migrate that as you test through those environments without having to re-register the systems to different repository or package sources. So there's a lot involved in Uyuni, but it's always good to know where things came from. So today, actually, I was inspired earlier when our keynote speaker this morning was talking about some of his history and what he had done in the past. My first IT job, I was in charge of a Quantel mini computer. Now, how many of you have actually used a Quantel mini computer, right? No one, because they don't exist anymore. But I was working for a company, and they had this system that they used for benefits administration. It was so proprietary, everything was proprietary on it. The internal pieces you had to buy from Quantel, even though the disk drives were Seagate disk drives, and if I bought the Seagate disk drive, it was $1,100. The same drive, formatted to work on Quantel, was $16,000. So I would try to hack these things. Back in the day, I was so frustrated with all the proprietary nature of things. I walked into my boss's office. I had learned the Quantel stuff. I looked over the shoulder of the engineers. I learned it. I did it because that was what I had to do for work. And my boss says to me, "You're the best Quantel guy there is." I said, "Oh, don't tell me that. I don't want to be pinned to this horrible proprietary technology." And a month later, they filed Chapter 11, and by 1992, it was over, right? So I think that frustration from all of that super proprietary thing has kind of propelled me into the world of open source. So it's good to know where things came from and where did Uyuni come from. Its origins lie with the Spacewalk project. Now, have any of you ever used Spacewalk? Yeah, some of you. Good, great. So Spacewalk was actually started in 2008 because Red Hat bought the company and open sourced it. So It was underneath Red Hat satellite server through version 5. And because Red Hat open sourced it, we're like, we don't really have, SUSE didn't have its own systems management tool. Let's take something that's open source and we'll do the good open source thing, contribute back upstream, and sell support for it and call it SUSE Manager. So we added a few elements, scripting to talk to our customer center, and voila, out came SUSE Manager. And then promptly, well, not promptly, but sometime after that, Red Hat announced they were in fact moving to a bunch of other new open source projects that would be underneath Satellite Server 6, Foreman, Catello, Pulp, and so on. We chose not to move there, but the project Spacewalk, as you can see from the website, actually stopped in May of 2020. So we created the Uyuni project to have something where our code could reside that would be useful for us and for our customers. And we named it after Uyuni the place, which is Uyuni, Bolivia. It's the gateway to the largest salt flats in the world. If you want to see some absolutely stunning pictures, look on the internet about the Uyuni salt flats. It's a beautiful, amazing place. So that's what we named our project after. And it's actually a fork of the Spacewalk project. So fork is a 4-letter word that starts with F, but it is not necessarily a bad thing when you find out the history of how this occurred. So we had been contributing to Spacewalk for quite a while, and suddenly Red Hat stopped accepting any new feature introduction, in part because they were trying to encourage their own customer base to move from Satellite 5 to Satellite 6, in part because they just could. So after 2 years of this, the distance between what we had built with SUSE Manager and what Spacewalk was widening. And when Red Hat was getting ready to stop the Spacewalk project, they put an announcement up on their webpage. We're looking for someone to take over the Spacewalk project because we moved on and we're doing other things. And we scheduled a meeting with them to talk about potentially taking over sponsorship and whatever of the Spacewalk project. And the day before that meeting occurred, the banner announcement went down off of the Spacewalk website, and those negotiations were unfavorable, I would say. That's sort of a euphemistic way to say it. It wasn't going to happen. So we actually forked the code, and we took the downstream and made it the upstream. So we took what was SUSE Manager at the time and did the rebranding thing. We pulled out the SUSE Manager names and put Uyuni in there, and we moved the code up there while creating a sort of informal project structure and a website up there for Uyuni. And all these things are things that we actually added to the code that were missing at the time of the fork. So SALT capability, which we put in there to resolve client communications and numerous other things. Scalability, which Spacewalk was woefully inadequate at scaling. Usability, some of the web UI changes that we made, we put back up into Spacewalk at the time. So under the covers of Uyuni, which has been going as a separate project since 2018, we have several important open source projects. Apache Tomcat OpenJDK are driving a lot of it. PostgreSQL is our database of choice. So that's what's running and gets populated with all of the stuff that you see in the web UI and the API. Salt is a key component both for client communications and for configuration management. And we also use Prometheus and Grafana for the monitoring tool, which I'm going to show you a little bit of, hopefully, if we have time in the demo. So Uyuni is the upstream project now for SUSE Manager. So we have a monthly meeting at the end of every month for Uyuni for you to be able to participate in and ask questions. At the community hours, typically we'll have at least one of the engineers that's working on Uyuni present what's coming in future releases. It's the last Friday of every month at 4 p.m. CET, which is Central Europe time, which turns out to be 10 or 11 a.m. Eastern, depending on how our daylight savings align. It runs on OpenSUSE Leap. We target to have monthly releases, but it's basically a rolling release project. So by rolling release, those of you who may not be familiar with that strategy, you don't get patches for what's out there. You wait for the next one to replace the packages, essentially. So you can import distributions, and what it says here is products, but so if you want to add something like CentOS 7 or Ubuntu 18.04 LTS, you can use a command line tool to create those channels, and you'll see that in the demo, what it looks like. In the paid-for version, you actually have a web UI that does those things, and that's really the only difference. We're not trying to make it a paywall product where the pay-for one is massively better. In fact, Uyuni is ahead of where SUSE Manager will be code-wise. So if you're looking at Uyuni, there's some stuff that hasn't yet made it into SUSE Manager, typically. So we also have translations. So we had community translation. So we had a community person in Japan that donated his time to build the entire Japanese translation. And we worked hard at coordinating that with WebLate and trying to make it useful. So we've had significant contributions on the translation side by the community, but we'll take whatever contributions you want to make, whether that's bug submission or usage feedback, anything like that that you want to do on the community side for Uyuni, or if you want to contribute code. We have people working right now on the errata for Debian-based distributions for Ubuntu first, and then it will be on the Debian 10, Debian 11 side. So those are fun things to watch the community do that are important and good. So our goal is to have a monthly release. So unfortunately, it's December and we're still on 2021-09. But there's a release that's due next week. I was hoping to have it for today's session, but QA held it back. So even though this is an open source project, the release manager works for SUSE, and he has access to a quality assurance team that runs it through before it gets pushed out to the community. So there's a cool feature that they're wanting to put in. It didn't pass QA, so it got pushed back to this coming week. So you can upgrade from the 2021-09 release to the 2021-12 release that's coming out. That is supported, well, supported in terms of we expect customers to be able to do this, and we've tested it. This is still a don't call me product, right? So don't call me. And it's been the upstream for SUSE Manager since 2018. So we've been doing it this way for more than 3 years now. And we have a great release manager who he actually also runs the community meetings. So very open for participation whenever you want to add things, have comments, test, play with it. It's up to you. There is a development version called Head or Master that is not tested, that will be broken. And this is where a lot of the stuff appears ahead of the general Uyuni releases. So if you really like bleeding, this could be for you, right? So here's the basic architecture of Uyuni. So you have a server, and above that server, I didn't put the icons on this one, you might connect to a source for repository content. So that may be Ubuntu's repositories. It might be Alma Linux repositories. It might be the SUSE Content Delivery Network or Red Hat Content Delivery Network. And that comes into the Uni servers. Clients can be registered directly against an Uyuni server. We actually have a Terraform script called Sumaform that will build out an Uyuni server and all the clients for testing and development purposes. You can also register clients through proxies, and this is a way of growing and scaling the product. So on an individual server, the largest one that we know of right now, a company in Italy, has 17,000 clients on a single server. I would not recommend that you start that way, but it can work. And we're scaling to a very large quantity of servers by using both the proxy things that are shown here and a new feature called Uyuni Hub. And Hub is basically an Uyuni server that has other Uyuni servers joined to it. And the content flows down. The clients don't see each other. The servers don't communicate individually with each other, but it rolls back up. And we just started the RFP for doing a data mining for that kind of gigantic, huge environment where you can look at reporting and see what's going on under the covers all the way down to the client side. Lots of Uyuni features you can use. I won't read all of these. You'll get to see some of them. Things like scheduling actions to happen in a chain of things. You have some monitoring that we'll also see. You can manage systems that are located anywhere, on premises, in the cloud, on a VM on your laptop. So I have systems that are on a VM in a laptop at my house, registered to an Uyuni server in the cloud. So Salt is very good at doing NAT traversal without having to open ports back down to the client. So excellent thing that makes it super simple for you to be able to be flexible in how you deploy things. So another thing that's important that we sensed from the very beginning after adapting Spacewalk is Spacewalk already had all this really good Red Hat-ish things. So why did we want to break it? And we chose not to break it. We chose to continue with the same API threads and keep support for Red Hat-based distributions. And in fact, we've actually enhanced it to support more than just Red Hat Enterprise Linux, but all the RHEL clones that we can find. Oracle Linux, CentOS, of course, and now Alma Linux, Rocky Linux. We had Scientific Linux for a while. How many of you are running Scientific Linux? Okay, that's the reason why we don't do it no more. So there you have it. So here's some of the operating systems that we support. Obviously, the SUSE ones are important to our enterprise customers, but we also support OpenSUSE, Ubuntu, Debian, RHEL, CentOS, Oracle, Rocky, and Amazon Linux too. So it might surprise you, but Amazon Linux 2, which is, if you go to Amazon, how many of you ever built servers in Amazon, right? Some of you. The default is to build an Amazon Linux one. Well, what is it? It's a RHEL clone. It has another kernel. It's sort of like a dune buggy, where you take somebody else's chassis and you bolt on a really cool engine. So they've kind of done that with Amazon Linux, but they have their own patch metadata, and errata structures, we import those natively into System Manager. So all the security patches, all the bug fix patches, you get to see all the details behind it, and you'll see some of that in the demo, hopefully. If you want to get started with Uyuni, so there's really good quick start guide that's here. If you go to uyuni-project.org, you'll look at the guides and you can find it. You start with an installation of OpenSUSE Leap. The current one is 15.3. That aligns with what we have validated for libraries and everything on the Uyuni side. Coming soon to an Uyuni near you, we're starting with the proxy servers in making it containerized. So by next summer, we will have the ability for you to deploy with either a Helm chart or with Podman, a containerized version of the Uyuni proxy, so it doesn't have to run on a VM at all. It's much faster to install, much more consistent. It takes, like right now in our labs, we're doing about a 5-minute deploy for the Uyuni proxy with containers. So it's 4 separate containers that are orchestrated together, but we're getting ready to do that with the server too. But for now, if you want to build a Uyuni server, start with Leap 15.3. That can be either in your lab, on your laptop, or whatever. Make sure you have enough RAM and disk space to be able to run this thing. So 8 gig is probably the minimum RAM. And if you're going to do multiple distributions, you're going to need lots of space to store that stuff because it's going to replicate the content down. And you'll see some of that in the demo, which is now. So hopefully you guys can see this okay. Yeah, good. Awesome. Okay, so we have an Uyuni server. This one happens to be up in the cloud, and I'm going to try it. Yeah, that'll make it bigger, right? So I have several systems that are here listed in my cloud server. So I have an Amazon Linux system here. I have an Alma Linux, and I have a Rocky, and I have an Ubuntu. So I did like an M&M bag where I have all colors. So each of these now is registered to my Uyuni system. So by default, they don't have the client necessary to register them. So what we're going to do is register another Amazon Linux system. Now you'll see that all of these systems say that they are system type of salt. So they are communicating with the Uyuni server using salt. And so those salt binaries are actually supplied by Uyuni. So for all the systems that we support, we don't make you go out to salt and pray that you can find the right one. We build a bootstrap repository for you and a tools channel for you to be able to install the salt client necessary to be able to talk to the Uyuni server. So there's really 2 ways for clients to talk. I install a salt minion, and that salt minion is actually running as a daemon on my client system. Or I can use salt SSH, which doesn't scale as well, and it's a bit less immediate, but it's kind of cool in how it works. So these are all talking salt, and we're going to add another Amazon Linux instance. So I have an Amazon Linux system running, and hopefully I can get there. So here is my this is my Uyuni server. And I have cut and pasted too many times. So I have a system that if I can ping this system on AWS. It's called DPV Amazon Linux Test 1. So we're going to connect this system to my Uyuni server. So you have, in order to be able to SSH in, you kind of have to have SSH open and a path to get from there to here. In this instance, my Uyuni server and my client are on the same network, so I didn't have to do a lot of firewallish things in order to get it to work. But we're going to connect our Uyuni system up to this guy. And hopefully I have my Firefox open. Here we go. So you can onboard a system with the user interface, and this is a practical way to do it. If you only have 1 or 2 hosts, you can do it this way, where I just put in the host name, I tell it what port, and of course this is Amazon Linux 2, so my user is EC2 user, and I'm going to use a private key. So I'm going to browse and select my private key from my local system here. So I've now opened my private key. I don't have any passphrase. Uyuni uses what are called activation keys. This is to help automate things. When you bring them on board, you can auto-install packages. You can assign it configuration channels. You can assign it to system groups, which are essentially tags. So I can tag it and say, okay, this is a database server. This is an infrastructure server. It's whatever you want it to be tag-wise. It could be geo, it can be function, however you use it. So I'm going to pick AL2 SSH. So this is Amazon Linux 2, and I'm going to communicate with it over SSH. I don't have a proxy in this scenario. I could add one if I had one, and then I'm going to tell this to manage the system completely via SSH and not install an agent. And when I click on the word bootstrap, now it's actually going to try to do this, and I should get a message up here. Right now it says blue, and it's waiting for a response. So once it registers to my Uyuni system, it will come back and this will turn green if I haven't done anything to tick off the demo gods this afternoon. So, and I'm hoping it's good because I already tried this once today and it worked. But even if it doesn't, hey, there we go, look at that. Now it's green and it says your system should appear in systems. And usually I'm famous for doing this when everything's go right. Woohoo! That's all right. You know you've been working on open source software for a long time when you get super excited that things just work, right? But oh well, anyway. There's a lot that went behind that. But now when I look at my list of systems, I should see my Amazon Linux 1 guy. Here he is. He's got an hourglass because he's still running some things. So when a system gets onboarded to Uyuni, he adds some entitlement. He does some additional salt states to assign it the right software channels. And then he appears in the list. So one of the things that you can do with Uyuni is a tool called remote commands. So here in Uyuni now, I can filter this list to have a subset of different systems if I wanted, or I could do an individual system, or I can just tell it to find the targets, and it will look at all of my systems. And you saw it matching the SSH push command to these systems, so it can now talk to them. And since they're all disparate operating systems, I can't exactly do the same command on all of them, but I certainly can do a uname -a and see what kernel is running on these guys. And when I click on run command, it does not do a centralized scheduler, and each task then sequentially wait behind that like Spacewalk used to do. This does an immediate parallel remote command send out to Salt. And Salt does the execution on the clients on their own clock. And you saw how how quickly things came back to my server. And I can, in fact, see the different kernels that are running. So on Rocky, it's got a 4.18 kernel. On Amazon Linux 2, it's running a 5.10, even though theoretically it's RHEL 7, right? And then my Ubuntu one, it's running a 5.4 kernel. So each of these, before I did all this, I synchronized the channel content. So I had all that software already on my Uyuni server. So when I click on software, you'll see I have all these channels selected. So I have Alma Linux 8, Amazon Linux 2. I even have OpenSUSE Leap here. The channels are defined, but I haven't synchronized any content. I have Rocky Linux 8. And you can see Rocky, actually, we have 2 architectures for Rocky. So if you have an ARM-based system, you can do that too. There is a whole long list of channels that are supported under Uyuni and architectures. So if you have one that is missing that you're passionate about, join the Uyuni project and encourage us to adopt more. So now I've got all of my systems here. One of the things that you can do with Uyuni is run salt states. So salt actually allows you, yeah, here we go. Okay, this is too small. Hang on. So this is another Uyuni server. This one is actually running in production at a school that I have worked with, and I've spoken here at Ohio Linux Fest about this a couple of times now. These 2 guys here in the middle have been partners in crime with me at this school numerous years. But here, this entire school is running on OpenSUSE Leap and CentOS 7. So we have 19 servers. This one is an experimental one, so it's not included in most of my controls and monitoring, but I can I've created an interesting salt state that you might wish to play with. So in configuration channels, you can create a salt state, and this one is called update everything. So it's a very simple state, and let me make this just a little bit bigger. All I'm doing is, no matter what operating system I'm running, Salt is going to do a package refresh and update everything, okay? And then I have a conditional reboot. So the conditional reboot looks at whatever OS I got and makes some decisions. So if I'm running a RHEL 8 clone, I need to use DNF to query about needs restarting. If I'm running a RHEL 7 clone like CentOS or any of the earlier ones, it actually uses that needs restarting from the command line. If I'm running Debian or Ubuntu follows in this, it creates this var run reboot required file when it's required. And on SUSE Linux ones, it uses zipper pf, and it does a query to see if zipper says it needs to be rebooted. So by doing this, I can apply the same state to my entire portfolio, regardless of what Linux operating system it's running, and it will apply all the updates and reboot. Now, I don't want to do that on my production systems, but I've created a system group called infrastructure. So if I look at my system groups in here, I created a system group, and this system group is called infrastructure. There's 8 servers in it. Some are CentOS and some are OpenSUSE. You can see they all have updates available. It's Saturday, first of all, so I don't care if I reboot these things. But second of all, these are a system group that's infrastructure. So these are not client affecting, these are like management servers. So I have backup servers in here. I have servers that run my imaging software, FOG. So I have a server that's my Uyuni proxy in the other building from where this one is. I have a server that's running Apache Guacamole for remote access. I have a couple of servers that are doing monitoring. So I can actually run this salt state that's associated with this group. So I've created inside of this group, I've told it use the update everything. And all I have to do now is click on execute states. It will update everything and reboot those boxes, right? So I can do that, or I can schedule a high state to occur on these systems and do that in future. So anytime you apply an individual patch or like a high state like this one, I can create a recurring. This shows me what servers it's going to apply to. And I can schedule it to happen at an earliest time. So this is not a time machine where you get to go back to yesterday and do the things that you forgot. No, it has to be in the future, so sorry. I wish I could give you an open source time machine, but not today. So we can schedule it to happen anytime in future, so I can tell it to happen at 4 o'clock after we're done with this. This is on Eastern time zone, so it says America, New York. So I can schedule this high state to occur at 4 o'clock later today. One of the things I referred to earlier and what's included in Uyuni is, how am I doing? I'm just doing about right. So is Prometheus and Grafana for monitoring. So what we do inside of Uyuni is we allow you, when I look at my list of systems, you can see they have the system type monitoring. All of them except for my test server that I don't really care about monitoring. I'm monitoring these guys with Prometheus and Grafana. So if I look at an individual server, like let's look at this one, which is a cluster node that's in a physical system in a building that I have. It creates what are called formulas. So when I click on formulas, I can choose to configure the exporters for Prometheus and Grafana. These are the ones where it collects the information from the client. How many of you are Prometheus gurus? Yeah. So yeah, some of you may have used it. So these are the exporters from the client, and it gives me a tab to be able to configure those exporters and tell it whether I'm using a node exporter, Apache exporter, Postgres exporter to get information from that box. And when I do, it automatically sets up that system with the necessary binaries, installs and makes sure the Prometheus exporter is running, and it becomes part of a scrape that happens on my Prometheus server. So in this list, I have a Prometheus server. It's called Nausus, not nauseous. Nausus. The school uses all characters from the Chronicles of Narnia, so we're pretty far down the list right now in terms of name selection. But Nausus is in there, and on this one, I have a formula for a Grafana server too. So it's added the other pieces to this box. I've already installed Prometheus. So I can actually look at my Prometheus server here. Come on. Okay. Let's go back. Okay, so this is my targets. And you can see all of my endpoints are being picked up by my Prometheus server. Plus, it's managing the Uyuni server itself. So it has a number of things that it's tracking. That's kind of okay. But what I really want to see is the graphical stuff like this. Whoa, looky there. This is my Uyuni server, and it's telling me the health of my Uyuni server. So I can see network, disk I/O, database operations, Java virtual machine health, things that correlate to Uyuni like the server actions and the Taskomatic centralized JVM scheduler and the health of all those things over time. And of course with with Grafana, you can drill into a specific time. If you wish, this one's on the last 12 hours. In addition, it picks up all of the client systems and scrapes those. So I can see each of these clients and what they're doing for the last amount of time. So I can look at the last 3 hours, for example, and kind of get some trending and see what's using a high CPU or what may be almost full of disk. This is all included in what we give you with Uyuni. And with that, my demo has actually worked. We'll switch back to our slides, not to that. Switch back to Keynote. And what happened here? That's music. That's not Keynote. Okay. Here we go. So what questions do you guys have? How can I help you? What would you like to know about Uyuni? Hopefully I can give you some answers, and I'd love to hear some feedback from you. Have any of you tried installing Uyuni yet? Yeah, a couple of you. Was it painful or okay? It was okay because I was there. Well, thanks, Trent. I appreciate that. No, it's really a relatively simple process. You want to make sure that you have some adequate disk space on your Uyuni server. So in this one, here's my Uyuni server. Here's what I have for disk space. Right now I have 330 gig that I allocated for the place where all the RPMs or the binaries get pulled down, and I'm using 194 gig. So please don't underestimate the size of your potential repositories, especially when you do an M&M bag full of different distributions like I did, right? I have one in my lab in Utah that I'm using 2.9 terabytes worth of downloaded content. I have every architecture and every flavor of every distribution we support. So it's somewhere between 300 gig and 3 terabytes. So, go for it. Any questions? Anything online? We okay? All set. All right. Well, join us at uyuni-project.org. We'd love to have your participation, especially we've inherited a lot of the people who used to run Spacewalk. If you have experience or you have systems management challenges that aren't being met by competitive product, we'd love to hear your input and have feedback. And thank you very much for your time today.